Hello and welcome everyone. My name is Mona Yadav and in today's video we will start learning about fluid mechanics. So let's start with the topic of introduction to fluid mechanics. So what is fluid mechanics? Fluid mechanics is the branch of physics and engineering that deals with the behavior of fluids. What are fluids? Fluids are liquids and gases. Now, how a fluid is going to behave, that means how liquids are going to behave or how gases are going to behave when they are in motion or when they are at rest. So, this is the study which is included in fluid mechanics. So, fluid mechanics is the branch of physics and engineering that deals with the behavior of fluids, how a fluid is going to behave when it is in motion or when it is at rest. Now, it encompasses the study of how fluids respond to various forces and how they interact with solid surfaces and each other. So, how a particular fluid is going to respond when it is under action of certain forces, or how it is going to interact with the solid surfaces which are in contact with the fluids. So, or how the fluid particles are going to interact with each other. So, this kind of study is included in fluid mechanics, that how a fluid is going to respond under certain action of forces. Fluid mechanics is concerned with understanding the fundamental principles governing the fluid flow. So, fundamental principles governing the fluid flow are like conservation of mass, which is also known as continuity equation, momentum principle. So, fluid mechanics is concerned with understanding these fundamental principles and as well as developing mathematical models and experimental techniques to analyze and predict fluid behavior in a wide range of scenarios. So, with the help of fluid mechanics, we can first understand the basic principles which are governing the fluid flow. Like the fluid flow can be studied based on these governing equations, and mathematical models can be developed or experimental techniques can be developed to analyze the new fluid flows or new system and predict the fluid behavior. So, in a wide range of scenarios, a lot of study has been done on various types of fluids, their behaviors, how they are going to behave, how they are going to act under certain conditions. And the scope is endless for the study in case of fluid mechanics, like how a fluid is going to behave under a certain set of conditions. So let's study about some fascinating features about fluid mechanics. So first one is ubiquity. So ubiquity means the property of being everywhere. So fluids are everywhere around us, from the air we breathe to the water we drink. Fluid mechanics governs numerous everyday phenomena, from the flow of water in the rivers to the flight of the birds, how birds fly in the air. So that is also governed under fluid mechanics. Understanding fluid mechanics allows us, like by understanding or by having the knowledge of fluid mechanics, what we can do, we can comprehend the world around us in better way. And understanding the behavior of fluids is also crucial. It's very important in numerous practical applications like engineering, meteorology, oceanography, biology, medicine, etc. So basically fluids are everywhere around us. So the water we drink or like the air we breathe in, everything, fluids are around us. And that's why by understanding the fluid mechanics, we'll be able to understand the things around us in better way. Second is interdisciplinary nature. So interdisciplinary nature means like fluid mechanics draws upon principles from physics, mathematics, engineering, and even biology and chemistry. It serves as a bridge. Now it is serving as a bridge between what? Various scientific disciplines, the laws, making it a rich area for interdisciplinary research. So it is becoming a bridge in between physics and mathematics. By usage of mathematics, we can understand physics in better way. So this interdisciplinary nature offers opportunities for collaboration and the application of fluid mechanics principle to solve various problems or diverse problems. Complexity. Next is complexity. So fluid mechanics involves a wide range of phenomena, like from the simple flow of water in a pipe, so fluid flowing in a pipe or water flowing in a pipe, to the very intricate dynamics of turbulent flow occurring in vortices or like a vortex flow. The complexity arises from the non-linear nature of fluid motion, which can lead to chaotic behavior and integrate patterns like uh, where the patterns where turbulence is created. So there will be chaotic, it will not be a linear motion of fluid particles, it will be turbulent fluid flow, and the particles of fluid will be moving in any direction. They will be creating vortices, eddy formation will be occurring, like the pattern will not be defined in case of turbulent flow. So, by understanding the fluid mechanics, the basic principles of fluid mechanics, we can understand the complexity behind the fluid flow. Next is beautiful mathematics. So, mathematical models used to describe fluid flow are elegant and often involve very sophisticated concepts from calculus, differential equation, and numerical analysis. So, basically, integration, derivative, and various differential equations along with calculus uh, are included in the study of fluid mechanics. The mathematical beauty lies in the ability to describe complex phenomena with relatively simple equations. So the equations which are formed under fluid mechanics, or which are already been formed and we are studying those equations. So those equations are making use of this calculus, differential equations, various things to make us understand the various types of fluid flows occurring or the fluid behavior occurring. So we can predict the performance by understanding these mathematical equations. The balance between complexity and simplicity makes the fluid mechanics both challenging and intriguing. Like, we can be curious about how a particular fluid is going to behave in a certain condition, or like this creates a lots of curiosity regarding more study in field of fluid mechanics. Practical applications. So, to understand the practical applications, understanding the fluid mechanics is essential for designing efficient transportation system or optimizing the industrial processes, designing aircraft and automobiles, like every system which is using fluid in some or another way. So by understanding the fluid mechanics, we will have the knowledge of various conditions where a particular fluid is going to behave in a particular way, and that will help us in designing that particular system. So understanding fluid mechanics is essential for designing like efficient transportation system, designing aircraft and automobiles, predicting weather patterns. So weather patterns can also be predicted by understanding the pressure in a particular condition, and pressure in a particular region over the ocean, over the particular region of ocean. So by understanding those patterns, we can predict what kind of weather is going to, like weather forecasting is done based on this. And like there are many applications. So, studying the behavior of biological fluids in the human body and much more. Like the study of blood, just like when we perform a blood test, that fluid is studied for various properties associated from the medical point of view. And it is helping the medical field for the treatment of patients in the better way. So the ability to control and manipulate fluid flow has far-reaching implications for technology and society. The field continuously drives innovation in areas such as aerodynamics, hydrodynamics, and heat transfer. So the spacecrafts or the aircrafts are designed considering the aerodynamics or hydrodynamics. So these are the fields which provide or which are continuously moving ahead based on the innovation happening in them. Challenges and unsolved problems are the next. Challenges and unsolved problems. So, under challenges and unsolved problems, despite significant progress, there are still many unsolved problems and challenges in this field, in the field of fluid mechanics, such as predicting turbulence accurately. So, still a lot of work has to be done in order to predict the turbulence in a particular geometrical field accurately. Understanding multi-phase flows, modeling complex biological system. So these are some of the challenges which provide ample of opportunities for exploration and innovation in this field. Uh, Next is visualization. So visualization, fluid flow often produces mesmerizing fluid patterns, like the fluid patterns which are even in the nature, on river or in waterfalls, we can see beautiful patterns formed by the fluid, that is water. So these fluid flow patterns are mesmerizing. And from the graceful motion of a stream to the chaotic swirls of turbulent flow, such as flow of smoke, like if we are burning a essence stick, so the pattern which is formed by the flow of the smoke, so that is also mesmerizing. This is the beauty of nature, but that can be understood from the point of view of fluid mechanics. The formation of waves, for example, the formation of waves and the patterns formed in clouds. So these are some mesmerizing patterns or the beauty of nature which can be studied through fluid mechanics. Visualization of fluid dynamics can be both beautiful and informative. Like we can get a lot of information. It's of course beautiful, it's elegant to observe, providing insights into the underlying physics. Like we can understand the flow physics behind that particular pattern by understanding the basic principles of fluid mechanics. So these visual phenomena not only fascinate, so the particular pattern which is formed in the sky or the river or waterfall or anything, these particular patterns, they not only fascinate the scientific field or the scientific community and engineers, but also inspire the artists and designers. So many designers and artists, they get inspiration from the nature or these natural phenomena. So overall, the combination of practical relevance, mathematical elegance, and interdisciplinary connection between the various fields and inherent complexity, the complexity involved in the fluid mechanics makes fluid mechanics a captivating field. Like if we start studying about it, then we will be very curious about what is further ahead. Of course there is lot of mathematical part, but that mathematical part is going to help us to study the particular fluid patterns or why a particular fluid is behaving in that way. So we'll be understanding about it in more detailed way, proper way, and that will be curious once we are interested in it. So these particular things makes fluid mechanics very captivating. So once we are attached to it, we'll always be interested in studying about fluid mechanics. And this is a very rewarding field of study for scientists, engineers, and enthusiasts who are interested to work in this field. Now, what are key concepts within the fluid mechanics? So the key concepts within the fluid mechanics include fluid properties. Let's see all of them and then study them one by one. So first is fluid properties. Second is fluid statics. Third is fluid dynamics. Next is flow regimes, various types of flow regimes. Fifth is conservation laws. Sixth is boundary conditions. And seventh is application. So these are key concepts within the fluid mechanics. So fluid properties. So understanding various types of physical properties of fluid such as density, viscosity, pressure, temperature are crucial for analyzing the fluid flow. We should be aware about what is the pressure or temperature or specific gravity or density of a particular fluid when we are trying to understand or study that fluid flow. Next is fluid statics. So fluid statics deals with the fluids at rest. Static means stationary. So when the fluid is in stationary condition, so we are going to study about fluid in that condition. So fluid statics deals with the fluid at rest and the forces which are acting on the fluids in that rest condition, such as buoyancy and pressure distribution in static field. So we'll come to these topics in detail when we'll go to that particular topic. Just now we are having introduction that why there is need to study about fluid properties, why there is need to study about fluid statics. Next is fluid dynamics. So under fluid dynamics, of course, dynamics means something which is in motion. So fluid dynamics focuses on the study of fluids in motion. So when a particular fluid is in motion, then we are going to study that particular fluid, and that study will be known as fluid dynamics. So fluid dynamics focuses on the study of fluids in motion. This includes analyzing fluid flow patterns, velocity distributions, and forces that cause and affect the fluid motion, whether the fluid motion is changed once force is applied in between it, or what is going to happen when a fluid is flowing and certain conditions are changed. So these all things comes under the fluid dynamics. Next is flow regimes. So, like fluid flow can occur in various regimes. Regimes mean in various forms. So, ranging from laminar flow, which is very smooth and orderly flow, the flow is in form of various laminars or layers. So, to the turbulent flow. So, fluid flow can occur ranging from laminar flow to turbulent flow. Now, what is turbulent flow? So, turbulent flow is opposite of laminar flow. As laminar flow is occurring in various layers, not interfering in between another layers, whereas turbulent flow is chaotic and it is unpredictable. So there can be formation of eddies or circular motion in between the fluid flow. So turbulent flow is not defined. It can have any pattern. It can have like mixed flow patterns included in it. So understanding the transition between these flow regimes, like when the fluid is flowing in laminar form, and then the transition is occurring from the laminar flow to the turbulent flow, just like when we are burning a essence stick. So initially the essence stick, the smoke which is coming out of the essence stick follows a certain straight path in particular direction, but after a certain distance it diffuses in form of waves or forming different patterns, and it diffuses in the atmosphere. So even though we are able to smell, we are able to have the smell of that essence which is there, but we are not able to see the smoke because it is diffused in the air, or it is diffused in the surrounding air. So initially the flow is laminar, but after some time the flow is turbulent in the like when we are burning that essence stick. So we'll be able to understand about these flow regimes, how fluid flow transition occurs from laminar to turbulent flow. Conservational laws. So fluid mechanics relies on various conservational laws such as conservation of mass, which is also called as continuity equation, conservation of momentum, conservation of energy to describe fluid behavior mathematically. So we need to have understanding of various conservation laws, or we will be able to have idea about various laws based on which we will be able to identify or study the complex behavior of fluids. So next is boundary condition. Fluid flows near to the solid surfaces are influenced or is influenced by boundary conditions such as friction, viscosity, like what are the properties on the boundary of that solid surface. Understanding these interactions is crucial for designing the efficient system and predicting the fluid behavior. So we need to understand, or we need to have awareness of boundary conditions. What is the condition of fluid when it is entering into a certain system, and what is its condition or properties, value of properties when it is leaving that particular system. So we need to have understanding of these boundary conditions in order to predict the fluid behavior properly. So, what are the applications? So, fluid mechanics has numerous practical applications in engineering, including now we have discussed it like designing aircrafts and vehicles, optimizing pipelines, various processes, HVAC systems. So, applications are endless for this field. Predicting weather patterns, studying ocean currents, modeling blood flow in the human body, and many others. So, there are a lot of applications for fluid mechanics. So let's learn about fluid properties first. So fluid properties. What are various fluid properties? Number one is density. Next is specific weight, specific gravity, viscosity, pressure, temperature, specific heat capacity. So we are going to learn these fluid properties in detail one by one by considering or by learning about its definition, how calculation of a particular property is done. Like if we are learning about density, then we will firstly learn about or study its definition. Then we will learn about how it is calculated, how the density of a particular fluid is calculated, what are its units, what are the units of density, like how it can be predicted or interpreted, how interpretation of density is done when we are aware of some other parameters and we have to calculate density, then how we can interpret it. What are the applications of density, like where density of a fluid particle or fluid is very important. So we are going to learn about various fluid properties by considering these points, that is definition, calculation, units, interpretation and application. So by learning these points we can provide a clear and comprehensive, that is detailed idea or explanation about these properties. So let's study these properties in detail in the next video. Thank you.